Number 8, each of the small boxes in the following figures is a square. How many different rectangles are there in each figure? Remember that square is a type of rectangle as well. Okay, let's start with the easiest one. So we can have single squares because they're triangles as well. We have singles 1, 2, 3, 4, and we also can have two squares form rectangle. So we have 1, 2. Remember, we have a vertical as well. So we have 2 in horizontal. That's 1, 2, and we have 2 in the vertical. So multiply by 2, that's 4. And we can have the 4 squares together to form one big rectangle. So add them up, there will be a total of 9. So let's work on this one. Again, we look at how many singles are there. We have 3 by 3, singles are 9. And we can have 1 by 2, which means we have 1 in the horizontal. We have 1, but we have 2 crossing this way. 1 by 2, we can have 1 and 2, and we have 3 rows. And remember, we can also have it vertically. 1 and 2 and 3 vertical columns as well. So vertically is the same as the horizontal, so 12. We can also have 2 by 2. 2 by 2 meaning we have 2 on the vertical and 2 on the horizontal, like this way. Remember, this one, horizontal, vertical, they're the same. So we have, you look at this way or you look at that way, these squares are the same. So we have 1, 2, 3, and 4. We only have 4. We also can have 1 by 3. So horizontally, we can have 1, 2, 3 together, 1, 2, 3 together, 1, 2, 3. So 3 horizontally, and we have vertically 3 rectangles as well. So double that, that's 6. And we can also have 2 by 3. 2 by 3, if we have 2 on the vertical, 3 in the horizontal, we can have 1, we can have 2, 2 for horizontal, and vertically we can have that too, 1 and 2. So total we have 4. And now we can have 3 by 3, which we use them all, so we have only 1. So add all these numbers up is the total number of rectangle that you can find here. So the students can follow the same strategies. First, we use 1 by 1, which means that's a single. And now we can use 1 by 2. And this problem, we can also have 1 by 3, 1 by 4, total 1 by 2, 1 by 3, 1 by 4, and 1 by 5. And we also can have, if you have, before we have horizontally only 1 square. Now adding on to that, we have vertically, we have 2 rows. Now we have 2 multiply 2, 2 multiply 3, 2 multiply 4, 2 multiply 5, and so on. And then we have 3 rows stacked together, 3 multiply 3. So don't use 3 multiply 2 because these will be overlapping to 2 multiply 3. 3 multiply 3, 3 multiply 4, 3 multiply 5, and 4 multiply 4, 4 multiply 5. Finally, 5 multiply 5. So I listed it this way so that they don't overlap, they don't repeat each other. So 2 multiply 3, when you have 3 on the vertical stack, you don't do 3 multiply 2. So the second number is always going to be equal or bigger than the first number, so that you can see that all the numbers that I've listed, there is no overlapping. So the students can find out how many rectangles for each category and add them up. Number 9, a train that is 1 kilometer long is traveling at 30 kilometers per hour. If the train enters a tunnel that is 1 kilometer long, how many time it will take for the train to clear the tunnel? So for this problem, so if we have a track that would go through a tunnel, then continue down the track. So the train enters here. at this second. The train itself is 1 kilometer, and the tunnel is also 1 kilometer. The only tricky part is when the train leaves the tunnel. The train fully leaves the tunnel with its head right here, okay? So the head is here. The total length for the train is 1 kilometer. So the train has to be right here when it fully leaves the tunnel. So the total distance it has to travel is not just the 1 kilometer distance for the tunnel. It also needs to add the length for the train. So this is the total distance has to travel, and you know the speed, and the student can find out how much time it would need to clear this much distance for the train.